Good afternoon. Thank you for being here tonight. This is our third and final in the three-part series for 2023. We'll be back next season. Right, Mr. Galway? We'll be back next season. Yeah. That's a resounding yes. Thank you for joining us. If you're here for the first time, my name is Deanna Udell. I have the privilege of being the Director of Communications and Public Relations for the Rosenstiel School. This series is intended to inform you, the general public, about our ongoing climate science research at the Rosenstiel School, as well as learn about how our research activities can help inform policy, all while we train the next generation of climate scientists. As you know, these types of events don't happen without the support of dedicated donors, so we want to take a moment to thank Mr. Galway, Bill Galway, who has been our presenting sponsor. Thank you, Bill. Bill has been a very loyal supporter for the last 9 years to our school. He also supports the Sea Secrets lecture series, which begins on January 23rd, so we ask that you join us for Sea Secrets for a really great lineup. Special thanks to Polestar. It's a new age of electric vehicle, our corporate sponsor for the Climate Café series. If you haven't seen the vehicle that's parked out front, there's a QR code on it. Learn more about it. It's really, really beautiful. So thank you to Polestar. Without further delay, because we have a lot to cover, let's get the conversation going. We'll have an opportunity for questions, as I mentioned. Regrettably, Jenny Stiletovich can't be with us tonight. She is recovering from a broken kneecap. Sending you good wishes for a quick recovery. Filling in for Jenny is Jenny's esteemed colleague, Tom Hudson. He is the senior economics editor and special correspondent for WLRN. Tom's extensive reporting on South Florida's economy has taken him from the waters of Florida Bay to the depths of the Port of Miami Tunnel and countless offices and conference rooms. He has interviewed bartenders and bankers, caregivers, and CEOs to report on the people behind the economic statistics. He's also well-versed in climate and its impacts to the environment and society. Tom began his business reporting career in March of 2000, just weeks after the dot-com bubble burst. He has reported from the trading floors of the Chicago Board Options Exchange, NASDAQ, and the New York Stock Exchange. He previously served as Vice President of News at WLRN when he created and hosted the Sunshine Economy for 10 years. He was managing editor and co-anchor of the Nightly Business Report on PBS. Tom, welcome to our campus. Join us on First Chair. So next I'm going to introduce our panelists, and if you could just hold your applause and give them one big round of applause, and we'll get the show on the road. So next up is Brian McNoldy. Many of you know Brian. He's a senior research associate in the Department of Atmospheric Sciences at the Rosenstiel School, who works on several research groups in various aspects of tropical cyclones. He regularly shares weather and climate information with a large following on social media, handles hundreds of media interviews every year on hurricanes, sea level rise, and local climate, for which I am most grateful, and maintains a blog on the Atlantic hurricane activity for the past 28 years. If you aren't already following Brian on social media channels, you should, especially during hurricane season. Brian, come on up. Ben Kirtman is our William R. Middleton III Endowed Chair of Earth Sciences with an expertise in atmospheric sciences, and he is the director of our NOAA Cooperative Institute for Marine and Atmospheric Studies, also known as CMUS. Dr. Kirtman's research aims to understand and quantify the limits of climate predictability from days to decades. Tiffany Troxler is the associate professor in the Department of Earth and Environment and director of science in the Sea Level Solutions Center in the Institute of the Environment at Florida International University. She is an ecosystem ecologist and sustainability scientist whose work cuts across science, policy, and management of natural and urban environments. She and her students examine how the Everglades ecosystems respond to sea level rise and water management and develop new research and tools to enhance their resilience to climate change. Her research group also advances interdisciplinary collaborative research that supports local to regional strategies and actions for climate change, mitigation, and adaptation. Welcome, Tiffany. Michael Berkowitz. Michael is the founding executive director of the University of Miami's Climate Resilience Academy. Michael founded and built the Rockefeller Foundation's 100 Resilient Cities from an idea into an influential global city network working across 48 countries to help cities around the world become more resilient to physical, social, and economic shocks and stresses. In his role, At the university's Climate Academy, he will build the overall vision, operation, and mandate of the academy and create the strategy and identify and prioritize core problems in which the University of Miami and its 12 schools and colleges are uniquely positioned to contribute solutions. So please give them a warm round of applause. Tom, all yours.
Thank you very much, and good afternoon, everybody. Great to see you. Jenny sends her regrets. She would be here if not for a broken kneecap, which is one of those injuries when you just say it, you feel it, even if you've never experienced it yourself. And I know that coming to a conversation like this, hosted by Jenny, is like coming to Biscayne Bay, hoping to see a dolphin, and instead showing up and seeing a lionfish like myself here. So she does send her regrets. That said, I do want to thank anybody in the House who is a WLRN member, who supports our work. Thank you very much for those folks who are WLRN members. Much appreciated. You are the power in the public behind what we do at WLRN. How about UM alum? UM alum in the room, faculty, students, staff. Let's see it, Canes. Wonderful. Great to see everybody as well in the room. Thank you for showing up for this important conversation. I'm excited. By the way, you're looking at, look at these four individuals here. This is a living Mount Rushmore of climate science. If the traveling Wilburys were involved with climate science, this is what the supergroup would look like. This is, you like that one better? Yeah, okay, the traveling Wilburys of climate science, maybe not the Mount Rushmore. Who was here in Miami this past summer? Who stayed? How would you describe, in one word, everybody say it. Right. June 11th through July 27th, 46 days in a row with a heat index of at least 100 degrees. First ever excessive heat warnings from the National Weather Service for Miami-Dade County. Ocean temperatures in the upper 80s to low 90s. Ocean temperatures. Over 100 inches of rain in Fort Lauderdale. A record temperature of 93 degrees on October 12th. 3.5 inches of rain at Palm Beach International Airport in a single day in September. More than 25 inches of rain at Fort Lauderdale Hollywood International Airport in April. Remember that day? And the flooding. 96 degrees on July 3rd. The highest ever recorded temperature in Key West. That was this summer. So, Brian, let's start there. Welcome to paradise, right? That's weather. But walk us through what that is indicating as we take a look back at the year that was in terms of some of these climate trends.
Thanks, Tom. I'm going to do a whirlwind tour here of some stats around the world and then more local to home. I'm going to start with extreme heat. So up here behind me, we got on the left side is the average temperature of Earth over the last, whatever, that goes back to the 1940-ish. 2023 was by far the warmest year on record. In fact, it was just a hair away from that 1.5 degrees C above the pre-industrial threshold that we hear and fear. So that's where that was for the world. You can see how far above even 2016, which we thought was crazy. Then in the upper right is the ocean temperatures, just the kind of the skin temperature, the sea surface temperature. Also, that thin red line way on the right side of the chart is 2023, way above any other year. That's okay. And then under that is a different measure of the ocean. It's the ocean heat content. So that's not just the sea surface temperature, that's how warm the ocean is through a depth. So that takes a lot more heat to make that happen. That was also a record in 2023. So the climate is warming, and so the atmosphere is warming, the ocean's warming, but 90% of global warming is happening in the ocean. So we're just here on land seeing a little snippet of it, but the ocean is taking the brunt of everything that's happening. And just a couple quotes there I'm not going to read, but they're there for you to read that, fairly ominous quotes from people who are working in this day in and day out. Not the best news. Okay, next slide, please. So zooming in here, these are taken from Miami International Airport, which has a record going back to 1948 at the same location. And so on the left side is just kind of the whole series of air temperature, which is the blue line, and then its trend. The green line is the dew point, or how humid the air is. And then the red line on top is the heat index, which kind of glues those two things into what we actually feel when we're outside. That's got the highest trend, of course, because when you have the air temperature trending up and the humidity's trending up, the heat index is really going to trend up. But this past summer was remarkable, not just that it was the hottest year on record here, but it was just, as you mentioned some stats at the start, it was just the intensity of it and how long some of the heat stats lasted.
Unrelenting was the word that I would say to myself every time I was able to get outside this summer. Unrelenting.
Yeah, right. And then so the chart on the right is the number of hours spent each year above different heat index values, 100 in orange, 105 in red, and 110 in the deep red. And they're a little bit hard to see, especially the 110 one. The 101 you can see pretty easily. 2023 was above the previous record. But the 105 and the 110 were like 3 to 4 times more time spent at that threshold than ever before. So we didn't just break a record, we cruised way past it by halfway through the year and kept on going strong. Okay, next slide, please. Gonna shift gears now, look at the oceans a little more. As I mentioned, 90% of global warming is happening in the ocean. And for this intro, I'm going to zoom way out. This is 800,000 years of history here. And there's a reason for this. So every few tens of thousands of years, we have glacial and interglacial periods where the ice caps melt, sea levels rise, ice caps freeze, sea levels go down. And that's 400 or 500 feet, every now and then, as you can see, huge differences. Okay, next slide, or next click, please. So I'm going to zoom into that red box. Okay, that's just the past 150,000 years. And what's noteworthy about this one is the last time sea levels were higher than they are now was 120,000 years ago. And at that point, we would be swimming with fish right here in this room. But not crazy higher than now, but definitely higher. We would be in big trouble. Okay, next slide. We're going to zoom in on that red box. This covers us from the end of the Ice Age, from the most recent Ice Age. Ocean levels have risen over 400 feet since that Ice Age ended, but they've been pretty stationary for about the past 4,000 years. So it kind of just quit rising around then. And then next click, please. We're going to zoom in on that teeny tiny red box up there and look at the past 1,000 years where it's been pretty flat up until about the last 100 years where it's spiking upward faster than we can measure practically. Okay, next slide, please.
What changed in society for that far, far part that shows that quick acceleration?
So I think one thing, can we get back to that last slide, please? If we can. Oh, sorry, we have to. Okay, there we go. What's important to mention here, and we can talk about this later, but okay, so the oceans have gone up and down by 400, 500 feet, but what makes this a problem for us? Who cares if the sea level is going to rise another 5 or 6 feet in the next 100 years or something? That's not a big deal, is it? Well, every place around the world built on the coast has been built there while the coastline was stationary. That's not true anymore. So every coastal location there is, like us here, lots of examples of very populated places around the world on the coastline are in big trouble. Next slide, please. So this is just zooming into here. These measurements are taken right here on Virginia Key. Our upward trend for the rate of sea level rise is about 1/4 inch per year. That doesn't sound like a huge number, but it's almost twice the rate of the globe on average. So it's very rapid here. The next chart on the right there kind of shows, okay, yes, thanks. That shows how much time we've spent each day above the mean high tide, with the newest year way up top there. And so as the colors warm up, we're spending more and more time above mean high tide. And you can kind of see, without even being able to read any of the numbers, that everything is warming. So we're getting higher tides throughout the year, but especially that king tide season in the fall is getting a lot worse. And then, next click, please. And then this is just the outlook. This is a fairly normally used outlook. This is the NOAA's intermediate high tide forecast. Well, forecast is the wrong word, but so that's looking at maybe 5-ish feet by 2100. And then next slide. I'm going to shift gears to hurricanes real quick, and so unlike the super trends in heat and the ocean, there's really no trend in hurricane activity around the world. There's 3 different ways of measuring that shown here. There's the number of named storms, number of hurricanes, number of Category 3 plus hurricanes, or major hurricanes we call them. And then the one in red is another metric called ACE, accumulated cyclone energy. They're flat. Like, you'd be pretty hard pressed to find a trend in any of this. So there's really no trend in hurricane activity around the world. Next slide, And then just zooming in on the Atlantic part, this goes back to 1850. And the observational record decays the further back you can, but this paper from 2021 adjusted that in a very smart way to kind of inflate those counts to what they would be if we had the observational technology of now. So again, in number of Atlantic hurricanes and in major hurricanes, no real trend. There's also no real trend in number of hurricanes hitting the U.S. But there are some climate change signals that we'll talk about, I think, later that I don't have on a slide, but we'll talk about it. And okay, next slide, please. And then lastly, just zooming in here on us, we've had 4 Category 4 and 5 hurricanes come ominously close to us in the last few years. This map shows the hurricane wind swath of those 4 hurricanes. And you can see that part of southeast Florida coast is not covered by any of them by some super luck.
Careful when a scientist used that 4-letter word, luck, by the way.
So next click, please.
Can I show that slide to my insurance carrier, by the way? Is that possible?
See, I don't need insurance. Hurricanes don't hit me.
That's right.
So this is looking at hurricane counts and the number of people in Miami-Dade County. The number of people is the orange line going up. We crossed 1 million people in the 60s, 2 million people in the 90s, and we're closing in on 3 million. The red and blue bars are the number of hurricanes and the Category 3 pluses, the major hurricanes. So I can click once, Deanna, please. In one 40-year period, the county got hit by 16 hurricanes, 10 of which were Category 3 and above. And then click. And the past 40 years, only 5. And only 1 was a Category 3. So what happens when our luck runs out? Like, how resilient are we? And if our luck runs out, how resilient can we rebuild?
Yeah. Well, what a sobering presentation there. Yeah, I'm not sure. That may get you more fans on social media. I'm not sure. But I really, sobering to look at those trend lines of what we've experienced just within the past few years and certainly centuries of millennia back then. So the United Kingdom was out with a forecast for 2024 in late December, and it forecasts that the global surface temperatures has a chance to be more than 1.5 degrees Celsius warmer this year than in pre-industrial era. So if you remember Brian's first slide when it saw that big spike that was just shy of 1.5 degrees Celsius, the Met Office in the UK says there's a chance that this year may be the year that we break that 1.5 degrees Celsius mark of global surface temperatures over the pre-industrial area, which is the threshold in the Paris Climate Accords to try to stay below with greenhouse gas emissions reductions and other measures. So, Ben, with that setup, we've seen what we've been through. Let's take a look forward.
Sure. I just wanted to make a few points in these slides here. This first set of figures are results from this Intergovernmental Panel on Climate Change, the so-called IPCC. This is climate model output and projections of the future, and very complicated figures showing all these panels and all these very different sets of curves that you're seeing there, and I'm going to drill down on a couple of these in a minute. And the point here, I wish this wasn't the case. As a climate modeler, this problem would be so much more fun and easy if there weren't humans. So humans make this really, really complicated because human activities are affecting climate. And that's one of the key points I really want to make. We talk about CO2 emissions, but we kind of really forget that that's us. That humans are setting up the trajectory that we're on. And so if you'll click one more time for me, thank you. One more. There we go. How do you like that zoom in? That was 2 hours.
That was good. Good PowerPointing there, Professor. Good PowerPointing.
Good
There's some
allocation.
AI that'll take care of that now.
Good allocation of time, right? So these are all those curves going into the future. The black curve is the historical record for global mean temperatures, and the various curves are that go into the future. They're based on different scenarios of human activities. We don't know what humans are going to do. We don't know. It's an open question. What currently looks like we're on perhaps one of those highest trajectories. The 1.5 degrees warming trajectory, that's sort of in that blue range there on those curves. And you're kind of starting to wonder whether that 1.5 threshold, that train has left the station. Maybe 2 degrees is more likely or even more. Next slide, please. And of course, for a climate modeler, the biggest challenge we have is figuring out what's happening with rainfall. And Tom quoted this 26 inches of rainfall in Fort Lauderdale this summer. That's just incredible in one day, just an incredible storm. As a scientist, really exciting, great stuff. For people in Fort Lauderdale, perhaps not so much.
You don't have a Fort Lauderdale address.
No,
correct?
right,
okay,
right. So for me, it was. But anyways, you can see all those different projections. They're all over the place. There's really no consensus at all about how human activities could potentially impact precipitation around the globe, and that's one thing we really, really care about. Certainly in Fort Lauderdale, they care a lot about it. So figuring that out, these are really big challenges. These are global means. This is the whole globe. That should be an easier problem than figuring out what's going to happen here. Next slide, please. So the second point I wanted to make is as scientists, we've set up this enormous infrastructure, huge amount of calculations, large number of 400 scientists participate in all of this, developing these projections. They help governments decide on treaties, planning, but they don't help us figure out what are we going to do here. How is Miami-Dade going to decide how to invest its $30 million bond fund to do climate change resilience, adaptation, whatever you want to call it? How are they going to do that? And that's an enormous problem. We've just barely started scratching the surface. Next slide, please. There we go. One more slide forward. So one of the things, I want to get rid of the words, thank you. One of the things that we've been working on here is all of those, some order 100 models all around the globe, scientists from everywhere, geniuses, brilliant people making these projections, giving totally different answers. How do we constrain that information so that you can make decisions locally? How do you constrain that? And so here's an attempt that one of my students made a few years ago to try to constrain the rainfall projections going out, at various timescales. Just look at the 2070 projections on the left and the right. They look a fair amount different, but they're brown. Same brown, no big deal. If the unconstrained projections verify, then the $30 billion we've invested, $30 billion in the Everglades restoration will be a success. If the ones on the other side where we constrain based on what we think is the best available science or which models we should believe in, the Everglades restoration will fail. $30 billion down the drain. Okay? So how we deal with this fire hose of information is a really tricky problem, and we need to engage the people that are making decisions and investing $30 billion and a lot less too, and making sure, next slide please, that we're providing the best available information. At scales, one of the last big challenge I want to talk about is, can we provide this at scales where people can make decisions? This is a study we did in my group. I don't remember things very well. I don't know why, but terrible memory. But I could remember this, so I set this up so the way I could remember it. When is there going to be a 70% chance that there's going to be 70 days of more than 7 inches of rainfall for more than 7 inches of water in front of your house for more than 7 hours? So, sevens. I like sevens, apparently. Lucky 7, right?
It's a lucky number.
Lucky number,
Maybe.
right. And so this is trying to look at, it's showing 6 and 1. I couldn't convince my student to use the 7, so she used 6. Shows you how influential I am. But the question is asking, when does that happen? And so the curves that Brian showed a minute ago are extremely useful. They're really important curves, thinking about sea level rise. But we also need to start to think about how we translate this information into how people are making decisions. So at your house, if there's 7 inches of water for more than 7 hours for 70 days, and you've crossed that 70% threshold, oh, poop. That's a big deal, right? You're going to probably change how you think about that house. You might, bug out or whatever you're going to do. So we need to think about crossing thresholds, and thresholds that are important for the decision process. And scientists, we don't do that very often. And so what I think is the important future that we're pushing here at the University of Miami and the federal government is pushing is this notion of doing the science hand in glove with the people that are making the decisions so that we develop guidance and information and trust, right? So if you're a decision maker and you see that fire hose of global climate modelers, what are you going to do with that? But if you work with us as a hand in glove and develop thresholds and, Ben, what if you did it this way? And I go back to the lab and I do it that way. And no, that's not what I meant. Do it another way. You develop that trust and they're part owners of that information. They're going to use it to make decisions. They're going to actually use it. So I think we're at this moment in time where people are clamoring for a good, robust information to make decisions, but the scientists, we're not doing that yet. And we need to interact with the people that are making those decisions, and I'm sure Michael and Tiffany will talk more about that. We're starting that process, but that's where when you want to think about what's going to happen in the future, that's from my perspective, despite how I feel about dealing with humans, that's where things are going to be happening. Anyway, I'll stop there.
The future starts now when you're looking at these trends, you're looking at the trends that set up that we lived through, that have happened in our lifetimes. The future starts today,
yes.
Right? Tomorrow is happening right now, and
exactly.
Making those decisions, even what we can consider at an individual size, at a macro scale. So making decisions for a community of 3.5 million people in Miami-Dade County, or South Florida of 6 million people, or Florida, 21 million people and counting, the United States, 350 million people and counting. Think about that neighborhood decision that you're happening. And as you mentioned, that the 7 inches for 7 hours for 70 days or whatever, maybe it's not a new car, maybe it's a John boat that I need to get
right.
for my,
right.
Maybe it's not a new porch, but a mooring that
right.
I'm going to have,
Canoe.
something like that, right? But you bring up the point, right? And this is Tiffany and Michael, where they come in, is really bridging that gap between the science and the laboratory, as it were, or the supercomputers, and individual action and certainly policy action, or at least policy decisions, Tiffany, about local resilient efforts, importantly, the important point here, informed by good science, informed by research.
Yeah, thank you so much, Tom. And 2023 climate, wow, we really got an eye-opener from these guys, right? And what's coming for the future. Yeah, and so when I think about it, I think about the impacts that these guys introduced of sea level rise, increasing temperatures, and increasing storms. And so as a sustainability scientist, I think a lot about how do we manage resources for our present generation and still enable future generations the capacity to meet their own needs using those resources. And that becomes very difficult in an uncertain climate future. Resilience is not only about making sure that our homes don't flood or we can get across the street because it's too hot outside. It's about large issues of water supply and maintaining our economy. The Everglades, as an example, we generate extraordinary, economic impact from tourism, fisheries economy. So a number of benefits that are resources that we're working hard to sustain in Florida, and one of those critical resources being the Everglades. And I'm so glad you mentioned that, Ben, because I actually think that we have quite a lot of experience in trying to understand how to work with, across scientists and resource managers to try to understand how we can tackle these large issues like Everglades sustainability. We know that the Everglades provides almost all of the drinking water to Miami-Dade County, and for up to 8 million residents of Florida. We know that the Everglades is a vast wilderness that protects that water supply and also protects us from storms and helps to promote that economic value that I talked about. And so one of the things that I've had the opportunity to do as a sustainability scientist working in the Everglades is understand how we can work across different disciplines, different types of knowledge. No, not quite yet. Yeah, that's okay. And working hand in hand with resource managers to try to understand how we can develop the long-term research infrastructure that helps us to understand, how we can foster resilience across our communities. And so this is just, one example of, one of our programs funded by the National Science Foundation, and right in our backyard here is the Florida Coastal Everglades Long-Term Ecological Research Program, where we've been working to try to provide the decision support to Everglades managers so that we can understand how we can continue to manage the benefits that the Everglades provides us in the face of an uncertain climate future. Next, please. And so what I think we have is an extraordinary capacity to leverage a lot of our learning and bring it into the urban space to try to understand how we can build resilience in our natural systems, our human systems, and our built environment. And I would say that working together across multiple institutions with the local knowledge that we have here across Miami-Dade County, we're really making some headway in this regard. And so in 2019, Miami-Dade County developed what is called the Resilient 305 strategy. Maybe you'll hear a little bit about it from Michael, but he was there at the beginning of that process, helping to forge that process, in fact. And so we built on that, working closely with our local academic institutions, including and Miami-Dade College, nonprofit organizations, local governments, to try to design a research and monitoring program so that we would be set up to be able to understand whether all the resilience benefits or all the resilience investments that we're hearing about, like a $30 million bond issue and all the funds that Miami Beach and the city of Miami have put forth to try to build resilience in these communities, so that we can understand, as those investments are being made, are we moving the needle on resilience? And are we also creating benefits for individuals that incentivize them to want to participate in the process and continue to enable the funding to continue to flow, because we're going to need a lot of funding to get a handle on this issue in Miami-Dade County. And so we set up the Resilient 305 Collaborative. Dr. Amy Clement is a co-director of that, along with myself, to evaluate the implementation of the Resilient 305 strategy. And I encourage all of you to take a look at it if you hadn't had a chance yet. 54 actions, comprehensive, hits everything from natural systems to financial capacity to impacts of epidemics. It's very comprehensive. It's a community resilience strategy. And it's gonna take a long-term approach to understand, as we are investing through the actions of that strategy, whether we're moving the needle and whether we're creating the co-benefits from those investments that help improve people's everyday lives. Next, please. And so what we've developed out of that is something called a resilience learning system. And it's the meat of it is that it's really focused at a neighborhood scale. So we've been working together in the collaborative across these multiple institutions to understand at a neighborhood level, what are people's priorities? What are the types of hazards that they are dealing with? And what can we measure to understand whether we're meeting the needs of people and their priorities in the places where they live? And so use that in a process to try to understand, through the implementation of those actions, are we moving the needle? Are we creating resilience benefits that will continue to promote people's quality of life? Next, please. And so some of the other ways in which we're tracking climate impacts at the neighborhood level is through observational data, direct observational data. And one of the mechanisms by which we do that is through citizen science. So all those green dots you see there, all those pink dots, that is all that distribution of those data points that you see on there of where we've observed flooding, where we have been monitoring heat and humidity, along with other stations that are managed by other institutions and agencies. The reason we have so many points on there is because citizen science. So I would say the data collection that we're able to do is supercharged by citizen science. The City of Coral Gables, the Miami Foundation were early adopters of citizen science and trying to increase our ability to directly observe the impacts of heat and flooding. But it's also a sort of a creative way in which we can engage residents to have a better understanding of what their climate risks are. And so we do, actually, in collaboration with Dr. Kirtman and other institutions, will hopefully be able, a proposal, hopefully we'll be able to continue some of these hyperlocal observations and continue to engage citizens in the process.
One thing Tiffany's not saying is really important. I just want to underscore her efforts here. There is no nationwide global network anywhere of flood information. How are you going to predict floods if you don't have any information of where the water is? How are you going to do that? So I can't underscore enough how important the network that Tiffany and her colleagues are putting together for these citizen scientists. It's foundational. We must have it.
Thank you, Ben. I think I have one last slide. And Noah has been a huge supporter of that work as well. So, but I don't want to leave you with doom and gloom, right? We have seen some pretty significant trends, and we're anticipating bigger impacts here in Miami-Dade County and in many locations. But 2023, we've also seen some advances. So I'd be remiss if I didn't say, talk about the Everglades just a little bit. That's one of my graduate students completely immersed in Taylor Slough headwaters. We're seeing more water coming into the park. more than we've had, since the CERP process has started, the Comprehensive Everglades Restoration Program. So this is good news. And the more water we can get into the Everglades, the better we can protect and promote the benefits that the Everglades provides us. We've seen pretty significant and pretty exciting integration across different types of agencies in work to build climate resilience and restore the Everglades. And those projects are being integrated in a way that are intended to create synergistic project benefits, so working across scales and across institutions. We've saw an extraordinary community advocacy, which has restarted what's called the Back Bay Project, the feasibility study, the coastal storm surge risk reduction planning effort that is now, we're going to take another look at it so that the distribution of the benefits can be more equitable and more multifaceted. And then finally, we've seen new investments coming in. The state of Florida, in 2023, about $18 million invested across the state in vulnerability assessments and adaptation plans for communities. The Economic Development Administration has established South Florida as a climate tech hub, and we're seeing a lot of funding flowing from the bipartisan infrastructure law in terms of the resilience investments that we need in Miami-Dade County.
Tiffany, thank you very much for that tour. I'm going to use a cliche that's probably banned here, but fish don't always see the water, and we're the fish. We don't always see these resilience efforts sometimes, and the amount of money invested is significant and is likely to grow. The attention on South Florida and Miami specifically from outside of South Florida as a place of real innovation around resilience is something that, frankly, we don't always recognize because we're in it and we're experiencing it and we're seeing our front yards or our neighbor's yard flood, and we want that fixed. But increasingly, South Florida is a global center of brain power, some of it here on the stage, luckily, with us today, but of innovation, technology, economic, addressing the solutions that are necessary in order to find the funding for the kind of resilient communities that are necessary. And this, Michael, this lands in your lap here as you are building that bridge and bringing some of those innovations to life and really trying to bring those to market.
Yeah, thanks. And it's true. It's really why I came, I moved here only a couple of months ago, really because I believe that this region and the university can be an exporter of resilience expertise. And not just solve our own problems here, of which there are many, but also help solve the world's problems when it comes to both climate change and other shocks and stresses. So that's really my point of view. And the Climate Resilience Academy is an integrated institute at the University of Miami, really meant to connect the university to itself across Rosenstiel and architecture and engineering and business and others, and also to connect that work, as Ben was saying, to community and to be really that link. And the reason why connecting the university to itself across these different disciplines is so important is because it's very hard to disaggregate all of the factors that are going in to what makes communities more fragile or more resilient. And if you think about the last 4 years, we've had a massive pandemic, we've had continued and sustained climate shocks, and we've had upheavals and spasms over equity. This is a picture from Santiago, Chile, but we've had Black Lives Matter here, and equity issues in Europe and beyond. So, and it's really almost impossible to talk about these things separately in some ways. And it might sound heretical on the Mount Rushmore of climate science, but it's almost hard for me to talk about climate resilience as opposed to just resilience, to modify that word. And I'll talk to you a little bit about why that is. I think it's a very useful entry point, especially in Florida. But the resilience is a kind of capacity that communities have to survive and thrive in the face of whatever comes next. So if you can go to the next slide, and let me talk you through that. This is a framework that I was working on just before I joined the University of Miami. It's very similar to what Resilient 305 was built on. This was done for an Australian foundation called the Minderoo Foundation, working on a resilient communities initiative in Australia. And if you, on the right-hand side, you'll see this is a whole of society approach. What are the capacities that communities have that make them more fragile or more resilient? And these capacities, so I'll just call your attention to the economic environment there. The more diverse, multiple industries, multiple sectors, the more vibrant it's growing, and the more equitable an economic sector is, the more resilient you are. And you can go around that wheel, the more cultural, the respected and empowered cultural environment that brings people together, that leverages historical indigenous knowledge, the more connected and engaged a social environment there are, and so on. We have lots of data to back that up, to show that communities with more of those capacities survive better in shocks, whether those are pandemics, upheavals, or climate shocks, than communities with less of those capacities. And so that's on the right-hand side. On the left-hand side, we've started to understand it's not just what you do, but how you do it. And that's what those principles are. The more community-led the action is, you build this muscle. And so when Tiffany's talking about community scientists, citizen scientists, it's like that muscle is going to be so useful after the next Hurricane Andrew, because you will have empowered people on the ground to understand this stuff. That's a form of resilience building. So, and really what we've been talking about, this next principle, risk-aware and forward-looking. Risk-aware. We've been talking a lot about risk awareness. These guys have made their careers in this risk awareness, helping us understand what kind of scenarios we need to plan for. And we know that the past is no longer a good predictor of the future, and so this is this forward-looking. How inclusive we are, how integrated we are, how accountable we are. So those are the kinds of capacities that more resilient communities have. And you can think about this, the lack of those things, and I'll just give you a very quick example of the fragility, the lack of these things and what that looks like, and then I'll talk in more depth about an example of what the opportunities are. So think about New Orleans and Hurricane Katrina. Katrina was in part about how big the storm was, how warm the Gulf was, how the levees failed, the flooding happened. But New Orleans was also, and you can find this right in these environments and these principles, was about the poor life chances in the lower Ninth Ward, about endemic racism, about failed governance structures, about working silos and isolation, FEMA not talking to the state, not talking to the city. Those are not abstract concepts. Those are real risk concepts about what made New Orleans a more fragile place rather than a more resilient place. And I just had this aha sitting on the stage looking at Brian's curve of the population of Miami-Dade that probably doesn't tell the whole story, because there's probably more social vulnerability, not just more people, but more social vulnerability up that curve. And so finding a way to represent that, because that is really what we're talking about when we talk about risk. The rich are going to be in air-conditioned areas. The rich are going to be able to leave. The rich are going to be able to rebuild. They'll be able to elevate their houses, all of those things. It's the more vulnerable communities that are going to be less resilient and that are going to bear the impacts and the brunt of the climate shocks that we're sure to experience in the coming decades. So that's the negative side of it. Let's talk a little bit more about what the opportunities are. And I'll take you to Paris. You can go to the next slide. So Paris, as you know, has had a couple of serious heat waves that's killed many hundreds, over 1,000 people. They've also had flooding. They had a couple of large immigration migration waves from Africa. They've had some terrorist attacks. And so how do you, with one intervention, start to touch different parts of those wheels in ways that builds a stronger, more sustainable, more resilient Paris? And one of the initiatives was they have almost 700 schools that they own, and those schools are largely have concrete playgrounds. Those playgrounds comprise of almost 700 acres worth of space. So individually, they're pretty small. Across the entire city of Paris, it's a meaningful, non-trivial amount of space. And what Paris did is they worked with the communities to redesign these interior courtyards away from concrete to more green features. And this started as a heat island intervention, trying to break the urban heat island, which was so deadly on its citizens during a couple of different heat waves. But by working with the community, by integrating rainwater capture and storage and permeable surfaces, by opening those spaces to community members on off hours and on the weekends, giving new immigrants places to go where they could learn what it means to be French and Parisian and European. They might reduce radicalization and isolation. All of those things are what we call the resilience dividend. Drive down the urban heat island, that's the initial impact. But build all of these other resilience capacities at the same time, making Paris stronger and more resilient for whatever the next thing is. And that's really the opportunity. So what does that mean here at the university? We just have so much, you can go to the next slide, we just have so much amazing work that's going on. And one of the things that we're going to do at the Academy is try to help stitch that together. So there's been great research by public health researchers. This is part of a larger sort of wave of data and understanding of the effects of greenery. But on the first slide, the first box there, you can see these researchers mapped green and not green blocks and found significant decreases in disease across a number of different diabetes, hypertension, and others. And one of the things we're doing in this community, this is happening at FIU, it's happening at is we're beginning to build new kinds of infrastructure and do place-based interventions. The number 2 is something called Sea Hive. It's like artificial reefs. Number 3 is this guy Andrew Baker who's growing climate resilience coral here. Number 4 is sort of place-based intervention. And what we need to do, here's where the integrating needs to happen. We need to better understand and capture the benefits that we get from, in number 1, and help change the systems, rating agency systems, regulator systems, federal funding systems, private capital allocation, because a 14% reduction in diabetes, why do we need philanthropy at all to pay for tree planting? We should be able to capture that value, and that should change the way we architect our cities. But we're really not doing it, and that's in part, I would argue, because too often we're thinking about that in these narrow silos and not more broadly. And so that's going to be some of the work, and really the work of resilience building going forward.
Michael, thank you very much. I've just committed that sin of thinking individually when I'm looking at that the green blocks reduce these chronic diseases, thinking could I provide my health insurance company with a percentage of my yard that's covered by shade and try to get a discount maybe on my copay, right? I mean, let's try to get down to that level, but think macro. All right, wonderful. Thank you for all 4 of you. I mean, it's terrific to be able to get through all 4 of these big minds on climate science within an hour, and I do want to provide a bit of opportunity for community conversation, because after all, that's a big part of this Climate Café series here at the University of Miami. So we've got one of our helpers here with a microphone somewhere here. Do you need to use this one? I will ask you to stand up if you have a question. We'll pass you the microphone. Please ask a question. There are no soapboxes in this room, you'll notice. If you get right to your question, then your neighbor will be able to ask his or her question as well, and we'll be able to get to as many as possible. So please stand up. Just tell us your name, where you're from, and then your question. Hi, sir.
John Nort, Coconut Grove.
Please keep the microphone close so we capture it on
Four
video.
generations here. As a kid in the 60s, we used to have a thunderstorm every afternoon at 2 o'clock. That came off the wetlands west of Miami. Those wetlands are now red roofs and parking lots. And Brickell Avenue never flooded until they paved it over. And so that's already happened, and I think your comments are very appropriate, and that's changed the climate of Miami. And 25 North runs right through Miami. Every landmass that crosses in this hemisphere is a desert, Mexico and Sahara. So we have a jewel here. We have to preserve the water in the Everglades, as I said. But the other thing is we've changed the climate with all the building that's going on, and with the city commission and their corruptness, they're not really listening to anybody. And I'll just leave it at that.
Yeah, a statement there, not a question, certainly. But some would say that a lot of that is based in fact, if not all of it. So Bill, thank you for sharing that. Go ahead, we've got, who's up next? Who's got the microphone? She'll make their way there. This is where we do our best Phil Donahue impression. For those of you who got that joke, thank you very much for the subtle and polite golf laughter there. Better than Jerry Springer, Bill, that is true, yes.
Yeah.
Hi, name, where you're from, and your question, please.
Yeah, my name is Nancy Gassman. I'm the Assistant Public Works Director at the City of Fort Lauderdale. And an alum. Yes, I am. On April 12th at 11 a.m., the forecast said we were going to get 3 to 4 inches of rainfall. And by midnight, we'd gotten 26 inches of rain. This created a community-wide PTSD. And every time it has rained since then, our phones ring off the hook because they don't believe the weather forecast. So my question is, do you think the current advancements in science will happen fast enough to restore the community's faith in the daily weather forecast?
Great question. Harder than it sounds, certainly for this group. And I think the room understands the difference between weather and climate. It's fundamental to understand. But anybody who'd like to tackle that? And Ben, I know that you've been working on some things that to try to bring some climate forecasting to the public in a way that perhaps is innovative.
I think one of the things you're going to see happening for extreme events like that is we're going to get better at saying what are the chances, of tomorrow of the rainfall being 26 inches. I think one of the problems is we issue weather forecasts as if it's a certainty.
Hold the mic up there.
Oh, I'm sorry. As if it's a certainty that it's 3 inches. And so everyone says, oh yeah, it's going to be 3 inches, and then 26 inches happens and people get, shocked and PTSD from that event. But I think if we do a better job of telling people, no, there's a 60% chance it's 3.5 inches, but there's a 10% chance it's, 26 inches, people will harden themselves for that likely outcome. So I do think we're going to get better at helping people understand the scope of the risk involved. Better, more granularity.
I'll just add to that. So when we hear like a deterministic forecast, which is the answer is blank, it's not really how forecasts work, it's just how it's presented to us, unfortunately. But if you think of a forecast, let's say for the day of 3 inches of rain, picture that in the framework of like a bell curve, and that 3 inches is right at the peak of the curve, but way out on the wings are these extreme events that ever so slightly could happen, but once in a 1,000 years or one in a blank, whatever your number is, they happen. And that's what that was. It was just so incredibly unlikely that no forecaster would have put that out there. It's such a fringe event that unfortunately happened.
Michael, yeah, please go ahead.
Yeah, I do think that the whole spectrum of weather and climate risk communication is something that we're going to continue to need to wrestle with because, and to find new ways to talk about those risks. And Ben's sevens is one of those, is an attempt at that. And I think, more of that is going to be necessary, especially when you get to climate risk, which is happening on much longer time scales, at larger geographic scales. And how do we begin to process that, I think is going to be really interesting. And we have a lot to learn from public health, who has been working on things like anti-smoking and seatbelts and safe sex and the other kinds of behavioral change campaigns. We can learn from public health in ways that would be really useful for this community, I think.
And I'll just add, I'm a +1 on the communications piece. As a public media representative here, communicating to folks in the public during times of weather emergencies, communicating clearly and accurately is and can be a challenge, as you experienced certainly in Fort Lauderdale. Fort Lauderdale, that day, it was a 1 in how many years event? So we're good for 999 years, right? I mean, that's the takeaway from that fraction. Am I incorrect, Tiffany? I mean,
Well, I was just going to offer that, we also, the way that we
giggle, but that's the way it's, that's the way you hear it.
No, that's right. And the way that we manage risk is, low probability, high impact events. It's low probability, so the chance of it happening is lower than a less catastrophic event. But when we're thinking about transformational change towards something that looks more resilient, it's about building systems that are safe to fail. If we do get a 26-inch, storm, we have other systems in place that can help to, bring the capacity so it doesn't affect people so significantly.
Safe to fail. What a phrase that is. Wow. Yeah.
Not mine.
Who's up next? Please go ahead and stand up. Where's our microphone? Do we have the microphone? She's coming. Stand by, sir. So name, where you're from, and your question.
Hello, my name is David Enfield. I'm a climate scientist. I used to work across the street at the NOAA lab, retired. As you're all speaking up here, and I enjoyed what you said very much, I started thinking about the thing that worries me the most is the difficulty in communicating these problems to the public. The process compared to a typical lifetime or a typical period that a person is living in any given place is very slow. So it brings up the analogy of the frog boiling in a pot of water. Why doesn't he jump out? So here we have this problem that the public, it's such a long time scale process. People hear about climate extremes, extreme weather on the news all the time, but you don't see it, how it's changing on that time scale. And to me, that's the biggest challenge we have. How do we communicate to the public when we have this time scale problem as far as perception of the problem?
You hit the head of the nail, and I think that's right. And Michael, maybe tackle that first, and Tiffany and Ben, you spoke about this, but it is if scientists like these talk about an overwhelming amount of information and data, fire hose of science, imagine those of us pedestrians who are just trying to process this, and politicians and policymakers that are trying to make decisions.
So I think we need an all of society approach. If you think about smoking, a scientist, the Surgeon General, said smoking causes cancer. And then we took the cigarettes out of actors' hands in Hollywood. And then we put these crazy pictures on boxes. And then we taxed and we regulated and we sued. And through all of that, then we've managed to change behavior in some ways. And I think we need something like that. I'm on FEMA's National Advisory Council, and one of the recommendations this year to the administrator was that FEMA help HERD as the nation's consequence manager. They may not be the right agency to do this or not. Maybe it's NOAA actually, but as the nation's consequence manager and often as the nation's risk communicator, they at least help align federal long-term climate risk communications in ways that are more digestible to humans. So but I think you're absolutely right. It's a massive timescale.
Name, where you're from, and your question. I know
Hi.
you. Hello.
My name is Carolina Flood. I have more of a statement than a question, but I'm hoping one of you can answer it. It kind of goes to what the gentleman just said. We're at the beginning of a national election, and nobody's talking about this. Like, this is not an issue. So if from that level it's not what everybody's screaming about, how do we trickle that down? And I think that's, everybody in this room cares about climate change, but how do you convince people, everyday lives that this is very important? That's kind of my question.
Bring these large macro issues, bring these graphs to life. Tiffany, this is part of
I mean,
your
I'll just
work.
say that was one of the motivations for starting citizen science programs, because the first time I saw a flood event in a neighborhood, I was shocked. It rolled in and it rolled out. And that condition where it's flooded 2 feet above the land surface is what we're going to be seeing in the not too distant future as a continuous condition without significant adaptation actions. So, maybe trying to use the present to illustrate what the future looks like.
I'll venture onto the thin ice here, and this election is not about policy. It's about a lot of personality. One thing, and I'll offer this as an idea, perhaps for a next Climate Café series, but to tie these two things together, a price on carbon. And I'm not advocating it, but a debate about that. I mean, when you talk about the analogy around smoking and all the actions that were taken there, seatbelts and those actions, driving under the influence in those actions, carbon pricing and really bringing economics into that, I think, is a worthwhile place. I'll just posit that for the next Café series here. Appreciate that. All right, who's next? We have a few more times, lots more hands. We'll do... Okay, however long we want to stick around. So as long as the lights stay on, right? We've got who do we have here?
Right here.
Right here. Go ahead and stand up. Hi. How about
Hi, I'm Dr. Cheryl Holder. I'm with the Florida Clinicians for Climate Action. And one of our concerns, which I didn't see fully integrated, is health. Because there are many populations that are now being heavily impacted by these issues right now. And much of the discussion sounds of risk mitigation for future. How are we incorporating that actual, like, how do I tell my diabetic who may be facing an amputation or interest or other health issues right now with the impact, and how are we monitoring that to help the population now and the future? And one other area that I don't know if is addressed is human migration, internal migration. How are we capturing that data so we can adapt rapidly, especially if a hurricane comes in the South Dade region where much of my population have moved to? How are we going to address some of those issues now?
Michael, you want to tackle it? You had mentioned the intersection with public health.
Yeah, I think there's a lot of different work. There's incredible intersections in terms of infectious disease, non-communicable disease, mental health issues, long-term stress like heat stress. The good news is there's a lot of focus on that intersection. I know so at COP there was a full day devoted to it in the ministerial level. There is a bunch of funding, I think, available to it. The National Academies of Medicine is thinking about it. We're going to focus on it at the university as part of the academy's focus. So this intersection of climate and health, there's already a lot of work being done. So I do think, and I think the resilience conversation and the health conversation, the social determinants of health, share a lot of common ancestry, because really what we're talking about are how to make communities more, vibrant, healthy, sustainable, equitable places. And so in that way, I think the resilience movement is really a good place to talk about this. So it's a good flag. I jumped over it quickly, but certainly a really important part of the climate conversation.
So the real reason that Jenny didn't want to come, because she didn't want to be the one to say, we have time for one last question. I will take that responsibility. So if we have the microphone, one last question. Go ahead,
Yes.
sir.
My name is Eric Swally. I'm the chair of our environmental committee from Davie. We need to reduce our greenhouse gas emissions. And one of the professors here, Nenyat Veziroglu, had written this book about hydrogen. And I'd like to know if we were to use all of the non-carbon renewables, solar, wind, and harvest the hydrogen from water. We have oceans of hydrogen. And if we were to harvest the hydrogen from water, we would have no emissions. You would have fresh water as an exhaust. And so I wondered if anyone here at the Rosenstiel would be interested in taking up hydrogen economy.
Anybody want to tackle the hydrogen
Have you heard
potential?
of it? I just wondered how much.
Tiffany?
I'm not going to tackle it, but are you talking about green hydrogen?
Yes.
Yeah. I don't know. Hopefully, some people at Rosenstiel will deal with that. No, I know it's an issue that it's a technology people are working on, and I think the issue is to understand the net carbon intensity of it, whether in a life cycle analysis actually illustrates that it's a net negative or
And
net neutral.
Working across those departments, Michael, in the academy and bringing engineering into climate science. All right, so I've got one final question, just in a sentence or two, and oftentimes this is asked. What are you asking of the community? What can the community member do? What can the neighbor do? What can folks here take back to Coconut Grove, take back to Key Biscayne, take back to South Dade County, Fort Lauderdale? Michael, I'll start with you, and then I'll just come down the path. What's that takeaway that you'd like them to think about, or an action, perhaps?
I think know your neighbors. That's one of the social cohesion is one of the single most important predictors of more resilient communities. So to the extent that we're not, isolated, bowling alone, whatever you want to call it, but rather have these connections is going to be really important. And really events like this are one way to do that.
I had a neighbor one time who knows what I do for a living. After Hurricane Irma, we were cleaning up our yards together, and I said, how did the kids withstand the storm? Because she stayed home. I happened to be at work. And she said, oh, it was fine. They were watching the Disney Channel. I was watching CNN. I mean, I figured they couldn't lie about the weather.
Talking to your neighbor, I think, is the first one. Getting out to the commission meetings and making some change. Voting, exactly. And there are programs that are offered by the city and the county that can lend additional support during extreme events. Like there's the Community Emergency Response Team training that any individual can take to lend extra support during times of after storms, and to try to help people that are facing the impacts of extreme events every day.
I guess I would say, first and foremost, don't despair. I think despair leads to inaction. So I think about your own carbon footprint, and try to reduce that, but also be wary of the one action bias. So there's this temptation, I bought an electric car, so I'm done. I don't need to do anything else. I don't think we can think that way. We have to think very holistically across all of our activities and actions to reduce our carbon footprint, and to act and to vote, and that's what I would say.
Okay, this is a hard one. I guess from my perspective, I would say be cautious of your source of information and what you consume, whether it's on conventional media or social media. Just be careful and be smart. This is a room full of informed and smart people, so I don't have to tell you this, but you know what I mean.
I have a suggestion for a news source here in Miami. If anybody needs one, feel free to come up and see me after the event today. So Brian, Ben, Tiffany, Michael, thank you very much. Thank you, everybody, to come. Thank you to University of Miami. And thank you, Bill, for your support to host this kind of cafe series. Thank you.
Thank you all very much. We will hopefully, well, we will. We'll be back for season 2. Be on the lookout for a survey in your email. We want to know how we did and what you would like to hear and see more of. Thank you very much for joining us.